Every time a child snaps together Lego bricks, they're repeating an idea that's over 5,000 years old. Long before plastic, people had already figured out the key secret. If you make many identical small parts, you can build almost anything out of them. Big, complex, sturdy things. And most importantly, if something breaks, you can simply replace the part. This video is about how humanity invented not a thing, but a principle. The principle of the building block. Let's imagine the world's first construction problem. You need a wall. The most obvious way, take one giant stone. Makes sense, right? One stone, one wall, no seams, no weak points. But this method has a massive flaw. A giant stone can't be lifted by one person. It can't be quickly replaced if it cracks. It can't be reproduced exactly somewhere else. Every such wall is a unique, unrepeatable feat. Now imagine you need to build not one wall, but an entire city, thousands of houses. Building this way is simply impossible. And somewhere between Mesopotamia and the Indus Valley, around the same time independently of each other, people arrive at the very same brilliant idea. What if, instead of one giant stone, you made 1,000 small, identical bricks? About 7,000 years ago in Mesopotamia, people begin molding clay in wooden frames. This is a critical moment because the frame guarantees that every brick will be the same size, not roughly the same, identical. And this is where real engineering magic happens. If all the parts are identical, you can combine them in an infinite number of ways. One brick alone means nothing, but 1,000 identical bricks? That's a house, a temple, an entire fortress wall. The parts stopped being a thing and became a letter in the alphabet of construction. By the 26th century BCE, in the cities of the Indus Valley civilization, Mohenjo-daro and Harappa, archaeologists find bricks with a remarkably precise ratio of sides, 4 to 2 to 1. This isn't a coincidence. It's a standard, and this standard is essentially the first technical standard in history. Long before anyone had ever heard the word engineering, someone had already worked out that 4 to 2 to 1 ratio purely through trial, error, and generations of quiet correction. But here's the interesting part. The building block principle breaks free from construction altogether. Look at cuneiform. A Sumerian scribe doesn't draw every word from scratch as a unique picture. He has a limited set of basic wedge-shaped marks. By combining them in different ways, he can write any word in his language. Sound familiar? This is the exact same leap in thinking as with the brick. Instead of an endless number of unique symbols, a finite set of simple elements that everything else is assembled from. And this leap repeats itself again and again across the most different fields. The Romans standardized the sizes of bricks and aqueduct components so that an engineer in Gaul and an engineer in Syria can build from the same blueprints without ever meeting, without ever speaking the same dialect, without ever seeing each other's work. Medieval armorers begin making interchangeable pieces of armor, so a dented breastplate could be swapped out mid-campaign instead of forged again from scratch. And Chinese movable type, individual characters that can be arranged to set any text, is the same building block principle applied to printing, centuries before Gutenberg ever cast a single letter in lead. Let's jump to the 15th century, to Venice. Here at the State Arsenal, ships aren't built from scratch each time. They're assembled from pre-made standard parts. Identical ribs, identical oars, identical rigging, identical sails cut to the same pattern. One ship a day. An incredible speed for that era, all because the parts were interchangeable. Foreign ambassadors who visited the arsenal described it as something close to sorcery. It wasn't sorcery, it was just modularity. 300 years before anyone had a word for it. 300 years later, the same principle is revived, first by the French engineer Honoré Blanc, and later by the American gun-making industry. If a musket's part breaks, you don't need to hand repair the whole musket. You just swap in the same part from another musket. This is a revolution, and it gives birth to the entire idea of mass industrial production. The assembly line, the factory, the modern economy itself, all downstream of one stubborn question. What if every part were exactly the same? And in 1958, a Danish company patents a plastic block with 8 studs on top. The company is called Lego, from the Danish leggot, meaning play well. But the idea itself, that a small standard part connecting with others like it can become anything, that idea was already 5,000 years old by then. The building block isn't a toy, it isn't a construction material, it's a way of thinking. Break the complex down into simple, repeatable, interchangeable parts. And then, from a limited set of elements, you can assemble infinite variety. We use this principle every day without even noticing, in the letters of the alphabet that all words are built from, in the components of a smartphone, snapped together on an assembly line halfway across the world, in the lines of code that a program is assembled from block by block, function by function. Even inside your own body, 4 simple letters of DNA combined and recombined, building every living thing that has ever existed. So the next time you see a child building a tower out of blocks, know this: they're doing exactly what the builders of Uruk did 5,000 years ago, exactly what the Sumerian scribes did with their clay tablets, exactly what the shipwrights of Venice did with their identical oars, only instead of clay or wedge-shaped signs or standardized rigging, they have plastic. The material changes. The idea never does.